So the topic for today's class is exception handling in Java. So in this class, we look at what is an exception, types of exceptions, exception call hierarchy, exception handling. We'll be doing a lot of code also. So what is an exception? An exception is defined like this: anything that does not behave in an expected way. So what is an exception? Anything that does not behave in an expected way. Anyway, I have some examples here. Say you take this example of a car. A car can face a lot of exceptions. What is the expected behavior of a car? You sit in it, you start driving, you reach your destination, right? So that is the expected behavior. But what kind of exceptions can happen? You can end up in a flat tire anytime during your journey. That is one of the exceptions. Another exception can be engine overheating. Maybe you revved your car a lot and then you went into engine overheating. That is one of the exceptions. And another exception is battery issue. There can be a battery drain. Maybe you was trying to start the car, or else a battery short circuit. Some kind of exceptions. And all these exceptions are serious exceptions, right? When I say an exception, it will stop the normal flow of the process. Say if you have a flat tire, you cannot travel, continue with your journey. If you have engine overheating, you cannot continue with your journey. You have to stop your journey. If you have a battery short circuit or a drain out, you cannot continue with your journey. So there comes, these are called exceptions. What are exceptions that doesn't behave in the normal expected way? What is the problem you face when you get an exception? Your entire flow stops. So if you are not handling these exceptions, say I get a flat tire, I'm not stopping my journey. I get engine overheating, but I'm not stopping my journey. Battery short circuit happens, I'm not stopping my journey. If you're not handling these exceptions, what will happen? What will happen when you don't handle such exceptions? Maybe you'll end up in a state like this, or sometimes full burnout of your car will happen. So this has happened to people who are not handled exceptions, I guess. So exceptions are very serious things. If you don't handle them, it will lead to very disastrous results. What we can understand here is it will stop the entire flow of whatever the process is. So how to handle these exceptions? That is the next question. So we'll take a look at this example here. Say I say this is an exception, this is an exception, this is an exception. I can give some ways wherein systems have been designed to handle exceptions. Say when you're going in for a flat tire, in a car you have a tire pressure monitoring system. There is a system in place to handle such exceptions. What is the use of this system? When the tire deflates or the pressure goes low, it will give you a warning. You can see here in one of the tires you have 24. So even before you face that serious issue, you will be getting a warning. That is because we are handling the exception here. Why we should handle it using a tire pressure monitoring system? So that you don't end up in a crash. You get a warning and then you handle it. Anyway, you're going to stop your journey. Maybe you have a pump to inflate your tires. You inflate it and then you reach your destination. So you have to handle your exceptions. For that, you use a separate process within your system. So tire pressure monitoring is for handling this exception. Engine overheating, how will you handle that exception? Have you seen this in your cars? This specific symbol, when it will be on your dial on your monitor. So when you switch on, it will be glowing for some time and then it will stop blinking. But after you turn on your engine, if this light still goes on, then it means you have an engine issue. So you have to look into that issue. You have to stop. You have to look into that issue. Say whenever your engine overheats, this particular specific symbol will start blinking. So how it blinks, there are some sensors which take note of the engine temperature and then it warns you. So why we are warning you? So that you don't end up in the full burnt out situation. Likewise, this is an engine monitoring system or heating monitoring system that we have here. Likewise, for battery drain out or battery issues, you have any separate process? Yes, you will see this specific symbol for batteries. So when you switch on your car, it will come on, and when you just put the keys inside, you'll see this symbol. When you switch on the car, when you start driving, that symbol will go off. But if this symbol stays even after you start driving, it means you have an issue with your battery. So there are systems and processes in place to handle every exception. So here we have a battery, maybe battery monitoring system, a separate system in place. Here you have a engine overheating monitoring system. Here you have a tire pressure monitoring system. For every exception, you have some handlers. You understood? Every exception has got some handlers. We have implemented every exception handler to handle that specific exception. Do you all agree? A tire pressure monitoring system will only monitor tires. It will not monitor engine overheating. There will be no overlap of monitoring here. Every system is specific for a specific exception. So are you all clear? So let me call these exceptions like this: tire pressure exception. Say whenever tire pressure goes low, I'll call that to be, I'll name that as tire pressure exception. When I say engine overheating happens, I'll call that exception as engine overheat exception. And battery exception, whenever battery exception happens, I'll call that to be a, I'm just giving my names here, battery exception. See, these exceptions are bound to happen many times during the lifetime of a car. It's not that you got a flat tire once, you'll never again get a flat tire. So every time a flat tire happens, your tire pressure monitoring system should throw you the data. What data it should throw? What is the pressure in all the tires? So engine overheating also, it can happen many times. So every time it happens, what you should get? Maybe the engine temperature, the warning light should glow. So there are certain actions with respect to the attributes. So battery exception. Now we'll focus only on one specific exception, tire exception. Say I'll consider this exception to be a class. Let's assume that tire exception is a class. I've written a class for that. Say something like this. Class tire pressure exception. What is this tire pressure exception is? I have two static private final integer values. Say in front tires 35 should be the standard pressure. In rear tires also 35 psi should be the standard pressure. So these are values that I cannot change. This is like the standard values for a car. And I also have four tire variables. So we have four tires here, and this is the constructor for tire pressure exception. What is the input coming into this class? The pressure in all the four tires. Let's assume that there's some sensor in all the four tires. It's sending the pressure to our constructor. And what it's doing, it's setting all the pressure to all the four tires. Next, we have a method check pressure. Very simple method. What it does is, if front tire 1 pressure is less than front tires, throw a message, throw an alarm. Likewise, front tire 2 is less than front tires, then throw an alarm. It's just checking for every tire, is it really less than the standard pressure we have? And how we are checking it? We are getting the input through the constructor while we are creating an object for tire pressure exception. And then we are checking this. So whenever a tire pressure exception happens, I'll create an object. What is an object? It's an object of type tire pressure exception. So when I create an object, what I should be passing in? The values for every tire. And then I will call dot check pressure. When I call dot check pressure, it'll throw me an alarm like this, because one of the tires, the pressure is less than 35. So why did we do all these things? Because of one concept, that is, every exception is a class. You all agree with that? Every exception is a class. And every time that exception occurs, there is an object being created out of that exception. So here I have created an object. Why I say it's an object? Because we have specific values for an object. So every time tire pressure exception happens, what will I do? I'll create an object, check pressure, and then throw the results. So an object is an instance of an exception, whereas class is the thing that is detailing the exception. We all agree with me on this point? That is, exception can be a class. An instance of the exception is actually the object. So what you're going to throw for every instance? The parameters. Whenever an engine heating exception happens, what you're going to throw? Engine temperature, which pertains to an object, right? What do you mean by an object? At that time, what is the engine temperature? That is an instance of that exception. So this understanding you should have. This is a very important understanding. That's why I'm giving you an example like this. So what we understand is, this is very important. An exception can be defined as a class. Every time an exception occurs, what you're going to do? You're going to create an object of that exception and throw the result to the user. So this thing you should not forget, that is, an exception can be defined as a class, and every time an exception occurs, what you do? You go to that specific exception class, create an object out of it. When a tire pressure exception happens, which class you are going to access? Tire pressure exception class. When an engine overheating happens, which class you will access? Engine overheating class. Likewise, when a battery drain out happens, which class you are going to access? A battery drain out class. So this understanding is very important. So likewise, programs also can have exceptions. So what do you mean by an exception for a program? Say you are expecting the user to enter integer values, the user enters strings. That can be an input mismatch, right? So your program may not work the way it should be. Maybe you're dividing two numbers, you're dividing a number by 0, that is undefined. So that is an exception. Not only that, memory for your system can run out. That is an exception. Maybe your hard disk crashed. That's an exception. You're trying to access a table, and I mean a SQL, a database table, but then such a table is not existing in the database. That is an exception. You're trying to write to a file, the file is not there. The file is corrupted. That is an exception. So anything can go wrong while you're running programs. So how you handle those issues? See, you can take your own VTOP, right? The university management system. You are asked to enter your user ID and password. Have you ever tried entering any value that you thought, any integer value, anything like that, other than your user ID? Say user ID can be a string, right? You're trying to enter some of your own values. Maybe you enter some space and then you press enter. It's not going to throw you any exceptions. It will handle those exceptions. It will say enter the correct username and password. So programs can encounter exceptions. That is reality. And when such exceptions happen, what are the two things we need when exceptions happen? Somebody should tell us this is the exception in this place. This is the type of exception. That is the first thing. Next thing is, when an exception happens, you can handle it. Handle it in the sense you can either warn the user or you can take appropriate actions as part of the exceptions. So programs also get exceptions. Let's take an example here. Input mismatch exception, I'll show you. Say enter two numbers is given. One is a number, Satish CJ. I've entered my name here. So that is a string. So in this case, I have coded my program only to accept integers. Dot next int I have used. But then what will happen here is, you would have seen this message many times on your screen. If you have not seen such messages, then you have not started programming. That is the reality. So you should have seen many exception messages. So this is input mismatch exception. See, this input mismatch exception is actually a class in Java. So inbuilt, when there is an input mismatch, that specific class is called and that exception is getting thrown as an object. So what is an input mismatch exception? You are expecting certain inputs of certain types, but different inputs are coming in of different types. Arithmetic exception is nothing but you divide a number by 0. You divide a number by 0 that is undefined. You don't know what is the result, right? So if you try dividing it, you will get arithmetic exception. Yeah, we'll start here. So what we'll do is, we'll just take in two numbers. We'll ask the user to enter two numbers. Very simple. Or we'll say enter first number, we'll say. So whenever you want the user to enter a number, what we need is, we need a scanner object to read the data. So scanner input is equal to system.in. So this scanner object we'll have, and one more thing is, we should get the value. Say int num1 is equal to input.next int, and we'll say sysout. Very simple code. Enter the second number, and int num2 is equal to input.nextInt. Now what we'll do is, we'll do a sysout and then we'll say num1 by num2. We'll just print the division of these two numbers, and we'll have a sysout saying thanks for using our software. Okay, very simple piece of code. Now we'll recreate these exceptions. Let's check. Let me run this code. So it should say enter first number. Let me enter 4 or 44. In second number, let me enter it as 0. Now the exception happened. What do you mean by an exception? It will stop the entire process. It will stop the entire flow of the process. For instance, you take a look at this place where the exception has happened. The exception has occurred exactly here. We are dividing number 1 by number 2. In this line, the exception has happened. After the program hits the exception, is it executing the next line? No. The process stops there. You're not going to run the next line of code. So here is an exception. So this is what the user is not interested in seeing. If you go and type vtop, your username and password, you should not show the user red messages like this. But internally, such messages are getting generated. That is the question. Can we create an input mismatch exception here? Let me run this again. So I'm getting in integers. Let me try and execute strings. So it's 1 and let me enter my name. So here it very well clearly says, what is this? This is input mismatch exception. Whereas the earlier one was an arithmetic exception. Okay. So we recreated some exceptions. We can recreate all the exceptions because of time constraint and limitation. Let me go with other exceptions here. One of the popular exceptions that most of the students here has faced, that is array index out of bound exceptions. Why it occurred? Very simple reason. You declared an array that can hold two values, whereas you are accessing the third element from the same array. So it says array index out of bound. Very popular error we get while you're working with array of objects or any arrays, multi-dimensional arrays, whatever it is. So you will get this exception. So who is catching this exception and throwing to us? Java virtual machine is doing it for you. So it is identifying that you are trying to access something that is not even defined. So what it does is it invokes this class, creates an object of it. Why I say it's an object? Because it gives you exactly in which line number, which class this issue is happening. Okay, so this is array index out of bound. There is another exception called string index out of bounds exception. So what is this exception? I have declared a string. I'm trying to access a character at a location in the string. See here, character at 6 is something that is not defined in the string. So this index runs from 0 to 5. I'm trying to access 6. So you get string index out of bounds exception. This is the error you'll get. So after this error, I mean this exception happens, nothing in your code will execute. The other lines will not execute. Null pointer exception, famous exception with array of objects again. I'll just give an example here. You have a string S, nothing is assigned, it's null. You're finding length of the string. So obviously you're going to get null pointer exception. Another popular area where you get null pointer exceptions when you create an array of objects and then you don't assign memory for each of the reference, but you try to access the objects. So that's where you get null pointer exception. Negative array size exception is there. What is this negative array size exception? I don't know anyone why he does that, why anyone should do this, but new int -2. You give a -2 inside your arrays, they are finding that exception too. You're going to get negative array size exception. That is there. Likewise, number format exception. This is like you're going to use a wrapper class integer a is equal to integer.parseInt. You're trying to parse a string to an integer. So this kind of a thing will not work, right? Even you're going to use a wrapper class, then you're going to get number format exception. File not found exception. We have not arrived at files, but very simple. Say you're trying to write to a file. This file may be missing or corrupted or it's not available or it has some privilege issues. So you don't have the privilege to write to the file or access the file. Then you will get an exception like file not found exception. File not found is the file is missing. You're trying to write to a file which is not even existing. Okay. Class not found exception. Have you faced this? Anyone? Class not found. So this mostly, I have faced this exception when I was working with JDBC. I was connecting to databases using JDBC. When you're connecting to a database, you have to use an external jar file containing a set of classes for this communication to happen. So I was not adding this jar file to my library. I was running code for connecting to a database. Since the classes were not available, it was giving me class not found exception. So this you may face while you're working with situations, while you're in a situation like this. So class not found exception, something SQL exception. So again, we have not done a database management system courses. So SQL is like a language used for communicating with your, I mean, executing queries on your relational database management systems. So actually you create tables on the database and then you insert values, you retrieve values, you delete columns, all these things. So when you're trying to insert data to a table, you're not created the table, you don't have the access to the table doesn't exist. So then you'll get SQL exception issues. So this is entirely to do with your SQL queries on the databases. So we have seen a lot of exceptions in programs. Say, what are those exceptions? IO exception. What is an IO exception? It can be input output exception. Like you're trying to write to a file not found exception is an IO exception. Class not found exception we have seen. SQL exception we have seen. And we categorize other exceptions as runtime exceptions. What are runtime exceptions? Arithmetic exception, null pointer exception, number format exception. Index out of bound is characterized as two types here, array index out of bound and string index out of bound. See, this exactly fits in a situation like this. You have a car, you have this tire pressure exception, you have engine overheating exception, you have what is this battery drain exception. So these are the different types of exceptions for a car, whereas these are different types of exceptions for a program in Java. And I have listed only few. There are hundreds of exceptions available in Eclipse. So I can't really explain to you all the exceptions. Some favorite exceptions I've explained. So you can very well view all the exceptions on Eclipse. I'll tell you how to view that. If you want to see the entire hierarchy of exceptions, what are the various exceptions that can happen on a program, or you want to know the classes that are inbuilt. How to know that? Let me show you this. Say you have an arithmetic exception, you have a null pointer exception. See, again, you have to understand this specific thing. That is, all these are exceptions, all these are classes. I shown you a class for tire pressure exception, right? Like that. All these are inbuilt classes in Java. They have already coded these classes. If you want to view these classes, you can very well view that. Say exception I'll create, and then I just type exception, open declaration. We can see the source code for exception. If you want to see the hierarchy of exception calls, say for instance, let me just select this and show you this hierarchy. Just a moment. Right click on the selection and then say open call hierarchy. When you open call hierarchy, you'll be able to see all the types of exceptions in this exception class. So you can see all these are types of exceptions. So when you take a look at this, you have timeout exceptions, lot of exceptions can happen, and we're not going to look into all these things. It's a lot of exceptions in the exception class. And under exceptions, maybe we can take a look at runtime exception. Where is this runtime exception? So you see runtime exception is a part of exception. When you click on runtime exception, you can see a lot of other exceptions, buffer underflow exception, buffer overflow exception. So there are hundreds of exceptions in Java, and it's not possible for us to go through all the exceptions, but at least you should have an idea of some of the basic exceptions that we encounter in our everyday programming. So what is this exception? When I say arithmetic exception, what is that? It is a class in Java. Can we see the class code for arithmetic exception? How will you see the class code for arithmetic exception? Let me type this. And when you open declaration, you'll be able to see, I'll close this call hierarchy. You see, this is class arithmetic exception extends runtime exception. So this is an inbuilt class. Whenever an arithmetic exception happens, what JVM does? Creates an object of type arithmetic exception and throws it to the user. You see that on the red screen, right? That is an object created by JVM, and it is throwing this arithmetic exception to you. But how this object is getting created? Using an inbuilt class. That's why you're getting the name arithmetic exception in red there. Likewise, do you have a class for input mismatch exception? Do you have a class for that? Say when input mismatch occurs, what JVM does? It just takes input mismatch exception class. Say let me open declaration. So you see there is a class for input mismatch exception. So JVM creates an object of input mismatch exception. Throws. What do you mean by an object? Under which class that error has occurred? What is the line number for that error? What is the error? That is an object. So this really fits in your tire pressure exception, right? Whenever an exception occurs, what is the pressure in the tire should be thrown. So there's an object creation done. The same way, an object creation is done for input mismatch. But again, what it adds, which line number of your code, what is the type of exception, all these things it tells you. So any number of times input mismatch occurs, this class will be used for throwing that exception. Is this clear? So input mismatch exception we have seen. Some understanding of this. This you should never forget. Each exception class is predefined, inbuilt in Java. These are inbuilt classes. You already have that. So every time an exception occurs, what you're seeing on the screen was just thrown to you by JVM. Java Virtual Machine captures this divide by 0, creates an object, throws it to you on red. But this exception is dangerous because it stops the entire flow of your program. So you have an exception class hierarchy, as I told you. What is on top of the exception class? So inheritance is in place inside Java source code. So you have the throwable class to be on top of the exception class, and then exception inherits throwable, runtime exception inherits exception, and input mismatch, arithmetic, index out of bound, null pointer, plus a lot. All these exceptions come under runtime exception. So I've shown you, right? Runtime exception extends. What do you mean by extends? Inherits exception. You even see that here in Eclipse, say, where is runtime exception? So you go to the Java class definition, runtime exception, extends exception. So what is this exception extending? Exception is extending throwable. There's nothing throwable is actually extending, I mean. So here, what you see with respect to exception handling is, which is the top of all classes, throwable. Under exception, you have so many different types. Under each type, you have subtypes. So this is the inheritance hierarchy. So whenever an arithmetic mismatch occurs, an object of this type is getting created and thrown to you. Whenever an input mismatch occurs, an object of this type is getting created and thrown to you. So that is done by the JVM with whatever examples we have seen so far. Are you all with me? Are you all able to follow this? So how to handle exceptions? Now comes the next thing. Say first thing is you have exceptions. You have tire pressure exception. You have engine overheating exception. So when the engine temperature rises, how to handle it? That is the next question. Likewise, we have arithmetic exception. We have null pointer exception. When it occurs, should we stop the program, throw the red lines on the screen? No. None of the software systems, professional systems will throw you such errors. So how will you handle that is the next question. We have a tire pressure monitoring there for the cars. Here what we have, we should handle it like this. As programmers, we should use these keywords: try, throw, catch. Very important keywords. Throws and finally also we'll see. Maybe in today's session, we'll focus on try, throw, catch. If time permits, we'll go with throws and finally. What is this try? What is this throw? What is this catch? I'll tell you how you handle these exceptions in the code. So wherever in your block of code, wherever you think the exception can arise, the problems can come. Where it can come, when you divide two numbers, definitely the user, there's a chance he can enter 0, right? So when you're dividing two numbers, some issues can occur. When you're asking the user to enter an input, he can enter a different type of input. So you can perceive, you can understand that, okay, here is in this block of code, I'll be getting such and such an exception. So what you do is you enclose that piece of code wherein you get, where you think you can get exceptions inside the try block. So I have put entire block of code where I feel I'll get arithmetic or input mismatch or whatever exception. I'll enclose that in a try block. This is how this is the first step. Next is, okay, when the user enters 0, a divide by 0 happens. So an exception object is generated by JVM and it will be thrown. So what I'm doing here is I am just catching that object here. So what is this catch arithmetic exception E? E is an object of type arithmetic exception. I'm catching that. And then inside the catch block, I can either print a message to the user or else I can print the stack trace, or I can take the appropriate actions, whatever it. After I catch the object, I can do anything. So who is throwing the object here? JVM throws the object here. Say when a divide by 0 happens, JVM throws the object here. How you are handling it? You are catching it. If you are not handling it, what will happen? It will throw a red message on the screen, stop your program. But when you are handling it, what will happen is it will throw a message to the user, and then the next line your code will execute. So here you can say, do not enter the second number as 0, and then the next line in your code will execute. Earlier, that was not the case. When an exception occurred, it stops the code there. It's exactly like what happens in your car. When your tire pressure goes down, you get a warning, then you slow your car, you park it somewhere without crashing onto some other vehicle. Getting a red message is like crashing your vehicle into some other vehicle. Whereas getting a message like this and then carrying out the necessary steps is like parking your car without any issues. So can we really catch the exception and see how it's working in code? Let me catch the exception here. So how to catch an exception? Let me go to the code we have written. Say what you have to do here is it's a simple thing. Wherever you think, okay, exception is going to arise, we know that arithmetic exception will arise here. So what I will do is I'll enclose the entire block of code where I think the exception occurs within a try block. Okay. And then what will happen when an exception occurs? JVM will be throwing an object. So I know an arithmetic exception will occur here, so I have to catch it. Catch is again a keyword. And what object I'm going to catch? Arithmetic exception object I'm catching. That's why I'm giving an E here, because an object is getting created of this class type. And then you catch it. Here I can put out some message to the user like divide by 0 not allowed. Something like this. And you see, I can have a sysout statement here. Good luck. Enter the correct input next time. Something like this. So why I'm having this sysout statement here is to say that after the exception occurs here, it is handled here. We are handling the exception and then we are letting the program proceed further with the other steps. So we're not crashing the program with a red line. Let's take a look at this now. So enter the first number. Let me enter 4. Let me enter 0. And now you see divide by 0 not allowed to the user. The next line after the exception occurs in your program. Good luck. Enter the correct input next time. So now the program is not throwing a red line to the user. You're handling it. Maybe you can log that error in a file and maybe the maintenance engineers can even look at it. Whatever corrective actions you want to take, that can also be taken. So that is the way you have to handle exceptions. Never ever your program should crash showing a red line on the screen. Now I have a question. I'm handling arithmetic exception here. What if an input mismatch occurs? What will happen? Will it catch that? Will it catch that? Say first number is 4, second number I'm entering my name Satish. Arithmetic exception it catches, but input mismatch occurs. What will happen? It redlines. That is like your car has a tire pressure monitoring system. It is not having an engine overheating system. That is the issue here. So now how to fix this? You should also catch input mismatch exception. So we can catch it like this. Catch. So you should catch all the exceptions that you think can occur in your program. So it's also an object. So whenever input mismatch occurs, JVM is there, takes the class, creates an object, throws it to you. So what you're going to do is you're going to catch that object and then you can say sysout enter proper input, enter only integers, something like that. So now we have two exception handlers, that is we are handling catching arithmetic exception, we are catching input mismatch exception. Let's run this and now let's check whether our input mismatch exception is also handled here. 4 and then Satish I enter only integers. Now which is getting caught? Input mismatch exception is getting caught and it's also executing the next line in your code. Like that, if you get null pointer exception, catch that. If you get file not found exception, catch that. For every exception, you have to catch it using this. And do you understand why we have separate blocks for each exception? Because each exception should be handled in a different way. An arithmetic exception handler should not be the same as an input mismatch exception. For those who don't understand this, a tire pressure monitoring system cannot handle an engine overheating system. I mean an engine overheating exception, I'm sorry. So likewise, say when a tire pressure exception happens, there are certain procedures that we have to follow. When an engine overheating happens, there are certain procedures we have to follow. That's why we are handling it in different blocks here. Okay, we are very lazy. We don't want to handle it in different blocks. Whatever exception happens, I want to catch that. What you can do that is you can catch all the exceptions using the base class. So base class exception can catch all the child class exceptions. Which is the base class? See, all the exception classes extend base class exception, and exception extends throwable. So here what we can do is we can catch exception E, and then we can say all exceptions caught here. So you're not going to handle everything separately. You can perform this. Say this will catch anything, null pointer exception, whatever exception comes in, we will catch. But what will be the message sent to the user? All exceptions caught here. Let's run this. So enter first number. So let me enter 1 and let me enter Satish here. What will happen? It will catch all the exceptions, all exceptions. Let it be null pointer, file handler, SQL, whatever it is. All child class exceptions can be handled by your base class. So all the subclasses, see all the exceptions will be under exception. So any exception you're throwing, any child class can be handled by your exception. That is your base class. But what is the problem with this kind of handling is, it's like a generic thing for all kinds of exceptions, but it will not miss out on any exception. And another thing here is you will get an error here if you have something like this. Say I'm handling all the exceptions. By mistake, if I handle arithmetic exception after this. So if I see I'm handling arithmetic exception alone, say I want to handle arithmetic exception alone in a different way, other exceptions in a different way. Then if I give arithmetic handled here. Now what is the error we are getting here is, this is unreachable code in exception handling. That is, whatever exceptions are being thrown, this guy is going to catch everything. Exception will catch everything. You will never reach arithmetic exception here. So this is unreachable code issue. You can see the error here, that is unreachable catch block for arithmetic exception. So what you have to do here is, you can very well handle it, but you have to reverse. First you have to put arithmetic exception and then exception. So whenever an arithmetic exception happens, it comes here, handles it. Any other type of exception will be handled here. Let me run this, show you. So let me run 1 and then say Satish, or else 0 I'll give. You can see arithmetic exception is handled. Whereas if I run and get any other input mismatch exception like that, what will happen? Say if I enter 1 and Satish here, that will go to the exception handler. All exceptions caught here. But it should never be the reverse way. That is, you should not have your base class exception to be on top and your child class exceptions coming below it. You understood what we are doing here? I want to handle all exceptions here, but when arithmetic exception comes, I want to handle that in a different way. I can do that. So who is throwing all these exceptions now? JVM is throwing the exceptions, and who is catching? The programmer is catching the exceptions. If you don't catch the exception, you will get that red line and your program will halt wherever that exception happened. Are you all clear? We have looked at two keywords now. What are those keywords? We have seen try, we have seen catch. So there is one more keyword we have to look at. Try we have seen, catch we have seen. What is this throw? What is throw? The meaning itself says throw. So you can throw an exception. Why to wait for JVM? I can throw this object whenever I want to. I can throw an arithmetic exception whenever I wanted to, instead of waiting for JVM. I'll tell you what this is. Let me keep this. Let me go back to code. So what JVM does, when a user enters the second number to be 0, it identifies arithmetic exception happens and then it throws. Now I want to throw my own arithmetic exception. Say if the user enters number 2 to be 2 or 3. If this is the value the user enters, what I am going to do is I am going to throw an arithmetic exception. I am going to forcefully throw an arithmetic exception. So what I will do is I will throw new. So throw is the keyword, new is the keyword, and then arithmetic exception. Now I'm throwing my own arithmetic exception here. See, second number is not a 0, it is a 3 entered by the user. but I am forcibly throwing arithmetic exception. Now what will happen? When 3 is entered, arithmetic handled here should be given. So how I throw this exception? Throw is the keyword. New arithmetic exception. What is new arithmetic exception? I am creating an object of type arithmetic exception and throwing it. So whenever an exception happens, you have to create an object and throw it. JVM was doing that. Now we are doing that. Let me run this. Let's check. What happens if we enter 3 to be the second number? 3. So first number is 1, second number is 3. Arithmetic handled here. How this was handled? Because I've created an arithmetic exception. Forcibly I'm throwing it and I am handling it here. So you can throw an exception. You can use throw new arithmetic exception. If a number we divide by 0, I can also perform something like this. Sys out e dot get message. What is this e? It's an object of type arithmetic exception. I'm calling get message, which is a method pertaining to that object. So what this get message does? Let's run our code and then let's see what this get message does when JVM throws the exception. So let's have first number to be 1, second number to be 0. Now JVM will catch the exception and throw it, right? Now what e dot get message is going to print? Divide by 0. So this divide by 0, did I give divide by 0 anywhere? So this is something that we have. We get this object from JVM. We are just calling e dot get message. What is the message printed here? Divide by 0. Suppose instead of divide by 0, I want to post my own message, custom message. Number 3 is not allowed. While I am creating this arithmetic exception, how I can override this message? What I can do is, while I am throwing, I can very well say, here in quotes, number 3 not allowed. So now what will happen is, what we are doing here, we are creating an object, and this is being passed to the constructor of the object. You all agree? This is passed to the constructor of the object. Where is this arithmetic exception class? It's here. Do we have a constructor here? You see, you are passing number 3 not allowed to the string, and this is passed to the super of s. What is super of s? This super method will pass it to the super method. It's super class, right? So this number 3 not allowed is being passed to the super class. What is the super class here? It will be going to runtime exception. Runtime exception, again, this is passing it to its super class, super of message. Like that, it will go to exception class. Exception also will pass it to its super class. So this message number 3 not allowed is traveling up the hierarchy of the inheritance, and then it goes to throwable. And in throwable, you have this constructor which is getting called. So number 3 not allowed comes here, and it populates detailed message with the message number 3 not allowed. And which method we are calling for this object? E dot get message. E dot get message is nothing but a method in the throwable class. Say public string get message is the method in the throwable class. We are inheriting everything. So from arithmetic exception, when I call e dot get message, it's printing the message I'm passing to the top of the hierarchy. So what we are trying to do here is this message. This goes to the super of s to the throwable class, gets initialized in the detail message, and then it's printed getting what is the method call we are making? E dot get message. Now let's execute this. Let me again tell you what exception I'm going to create now is I'm going to create this. I'm going to enter number 2 to be 3. When I have this exception happening, an arithmetic exception will be created. What will be passed to the constructor? This will be going to the throwable class, and then it will be initialized in the detail message. When I do e dot get message, what I am calling object dot get message, what will be printed? The detail message. Let's see whether we are able to override that message. So you see, let's enter 1, and the next number I'm going to enter as 3. Number 3 not allowed. So this is how, say, when you're calling methods of E, you are actually calling methods in the throwable class. Any method you're going to call E dot, it's actually present in the throwable class. All the other exception classes are like this. It has just 2 constructors. One non-parameterized, another one is parameterized. Any exception class you take, you're going to have just two constructors. Okay. Are you all clear with this? How to use try, throw, catch? Any doubts here? What is the use of try? Enclose the code using try block wherever you think an exception will occur. What is the use of catch? Catch all the types of exception objects that are getting thrown. It can be an arithmetic, it can be input mismatch, it can be null pointer. If you want to catch everything using one exception class, use exception. Exception E will catch all the exceptions. What is throw? Use of throw? Throw will, you can use throw keyword to create an exception object and throw that. Possibly you can throw an exception wherever you want. Throws, and finally I will come to that. Before winding off today's class, let's go with one more simple concept and then we'll wind up. Throwing exceptions with custom message also I told you how you can override the custom message given by JVM. User defined exception. So now this is interesting. I'll wind up after this. So what is this user defined exception? Say what are inbuilt exceptions predefined? Arithmetic exception is a predefined class. User defined exception is I can create an exception class called Satish exception. What Satish exception is? It can be anything. When the user enters number 13, throw Satish exception. So it is a class that you define. But according to the rule in Java, every exception class, it be user defined or predefined, everything should extend. It should extend exception. So this is one mandatory rule. If you write your own user defined class also, you have to extend the exception class. So I'll just go with code and then end this. Let me tell you how to create my own exception and throw. So we'll take a look at an example for user defined exceptions. Whenever we are talking about exceptions, we were talking about these things, right? Try and we have a catch block to catch the exception. So this is important. Whenever you have a try block, it should be followed by a catch block. Please have this in mind. So what is the use of a try block? Wherever an exception is bound to arise in a code, you will enclose that using the try block. So here is where your code will be. So this is where the exception is going to arise. So you're going to enclose that within a try block. After a try, immediately you should have a catch. If you don't have a catch block, you'll get an error here. What is that error? Finally, to complete the block statement. So it's like you should follow that with a catch. You can also have a finally block. We'll discuss finally soon. You can't have any other statements after try. Say something like this. You can't have any sysout statement and then you can't have a catch block. So immediately after a try, you should have a catch block. Say I can ask the user to enter a number. Just say enter a number, and we'll have a scanner object to get in this number. Scanner input. It's a very simple scanner. What we'll do here is we'll get this number. Say int num is equal to input dot next int. And I just throw an exception here. If num equals to, if number equals to, the value entered by this user equals to, I want to throw my own exception object. That is something like this. How will you throw an exception? You have to use throw keyword, throw new. I want to throw an exception object like this, Satish exception. Right? Something like this. And then I have to catch Satish exception here. How will I catch that? Satish exception. I have to catch this object here. And I should also print some message here. What is that message? Number 2 is not allowed, something like that. Simple thing, we have done this earlier too. So now there is an error here. That is because it doesn't understand what is this object of type Satish exception is. So when you're creating an object, you should have a class for that, right? So you should have a class. Let me define a class for this user defined exception. So what is this? This is this Satish exception is nothing but an object of type user defined exception. We are defining what is this exception. So let me create a class for that. Since you're throwing an object, you need a class. So Satish, exception should be a class here. Let me type this. And the mandatory rule, whenever you're writing your own user-defined classes, you should extend exceptions class. Okay, now all our errors are gone. That's because we are throwing an object. Object is of type this particular class. So you'll be able to throw this. Let's run this. This is an user-defined exception. You can write your own exception classes. You can throw it whenever you want for any scenarios inside your program. So enter a number. If he enters 2, number 2 is not allowed. So what happened? When this user entered number 2, an object of type Satish exception was created. How it created that? Using this class. And it was throwing that object. We are catching that object here, and this message was thrown. So this is an user defined exception. We were also looking at one more thing. Throwing an exception object with your own custom message. What is the custom message I was talking about? Say I can put a custom message here. Satish throws this exception, something like this. And whenever an object is created and thrown, this message should be printed to the user. So here what we'll do is we'll catch this, and instead of printing our own message, what we should do is we should call e.getMessage. So when I call this method, this specific message should be printed. So how the specific message can be printed? For that, what we should have is we should have a parameterized constructor in our user defined exception class. So let's go with this parameterized constructor here. I'll call this string s, and whatever message I'm passing, I'll pass it to the superclasses. Or else I'll just say this is exception thrown. Let's not have a big message, exception thrown like this. This is the message that should be printed whenever I call this method. And now this is getting printed. Say when I create an object, this is getting passed to the constructor, and this is getting passed to the superclass. Here the superclass is exception. So when you go to the exception class, what is there? So it's going to get the message here, whatever message exception thrown, it will pass it to its superclass. What is the superclass for exception? Throwable. So when you go to the throwable class, so what it's going to do is it's going to get that message. So we'll see where that message comes in. So you see here, this is the throwable class constructor, not this one, this one. So this message is coming to the throwable class. It is getting initialized in the detail message. Why we have to pass it all the way to detail messages? Detail message is a private variable in the throwable class. You can't access this detail message in your derived classes. And what this detail message is getting assigned as whatever message we have sent. And when you call this get message, what is this method get message? When I call, what is getting returned? Detail message. This is the inheritance hierarchy available in exceptions. So you have to follow this, and we'll run this code. Let's check whether this one really works, and what we should get, this message we should get when we call e.getMessage. So this message is passed to the throwable class detail message variable, and this method will actually print whatever value is assigned in the detail message variable. So let's run this. Let's check whether we are getting the output. So when I print number 2, exception thrown should be printed now. So still, some of you might be in a confusion here. So I have created some visualization here for you to understand this. So what's happening here is we are creating an user-defined exception. We are passing this message exception thrown. So this is of type Satish exception, right? So what happens is this message is actually getting passed to the constructor in this class. And what this class does, passes that to the superclass. So what is getting passed to the superclass? So exception thrown is coming here, and it is getting passed to the superclass. What is the superclass for Satish exception? Exception. So now this exception thrown message will be passed to the superclass here. So it comes here, exception thrown is passed to the message variable, and this in turn is passing to its own superclass. So what is the message that we have here? Exception thrown. This is what we are passing, right? This is passed to its superclass. What is the superclass for exception? Throwable. So now you have this class throwable. So exception thrown comes here and it is getting initialized to detail message. So this is a private variable inside your class throwable. And when you call get message, what is getting printed? The detail message. What detail message is going to have? Exception thrown. So whatever value you are passing is getting transferred to your superclass and it is getting printed as part of get message. So when I am calling e.get message, what is happening? Detail message is getting printed. So this is what we have used in our code here. So that's what we have used in our code here. While you are throwing the object, you can override the message. Okay. What is the next concept we are going to take a look at is inheritance between user defined exceptions. What is inheritance between user defined exceptions? Say I'm throwing Satish exception here. When I'm throwing that, when I get number 2, maybe when I get number 4, I will be throwing another Satish exception. So I have a list of exceptions called Satish exceptions. It's like a list of runtime exceptions you had, right? All the runtime exceptions you can think of. So like that, what I'm trying to do here is I'll have this class Satish exception to be the base class for all the kinds of exceptions called Satish exception here. So Satish exception extends exception. So I'll just say this. And what I will have here is, say whenever number 2 comes in, I will be throwing Satish to exception, which will extend Satish exception. So there is an inheritance hierarchy here. Likewise, whenever number 3 exception happens, what I can do is, I can say it is Satish 3 exception extending Satish exception. So what is that we see here? This is the base class for Satish exceptions. Whenever number 2 exception comes, there is Satish 2 exception, which extends Satish exception, and this one extends exception. So we can have our own hierarchy of exception classes, user defined exception classes in Java. That is possible. So why I am doing this? Because I know all these exceptions are coming under this kind of a category. So you can have such hierarchy within your user defined exceptions. Say I'll just throw an example here. Say when number 2 comes, I'll throw number 2 exception. I'll say number 2 not allowed, something like this. Number 2 not allowed. And if number 3 comes in, what will I say? Number 3 not allowed. So I'll throw the another exception here. Num3 not allowed. But you're getting an error here. Why are you getting an error here? Why are you getting an error here? Because you didn't have the constructor specified. Say whenever Satish 2 exception gets thrown, I'm passing a message. I need a constructor here, that is parameterized constructor I should be having here. So it is string s, and I should be passing this to my superclass, throwable class, I should be passing it. Likewise, the same thing should also be applied for Satish exception, because this is going to call this is superclass, this is the superclass. You understood? When I throw this exception, this will call this, because this is inheriting this, and this will call this, and that will call throwable. So again, here you should have a parameterized constructor. That's why you are getting an error here. You have a parameterized constructor there, and you also have a parameterized constructor here. So now all our errors are rectified. Let's run this. Let's check the output. So if I'm going to pass number 3 not allowed. How it happened? You are overriding the messages here. So this is what I was trying to tell you. You can have your own user defined exceptions defined, and you have a lot of other user defined exceptions that can be categorized under a certain category. Say all the exceptions of a certain category can be falling under one of the exception classes. So that is possible for your user defined exceptions too. So are you able to follow what is an exception? Now let's take a look at throws class. What is the use of throws class? Have you all understood what is the use of throw? Throw will be used for throwing a new exception object. There's a difference between throw and throws. Throw is used for throwing an exception object. What is throws? I'll give an example directly so that you understand throws. Say I have a method like this. I'm going to call this method in my code. Say this method is already inbuilt available in Java. Say you're calling math.square root, right? You're using a method call here. Dot square root is nothing but a method inside your math class. Likewise, input is nothing but, when you say input dot nextInt, what is nextInt? Is a method inside your scanner class. So when you're calling the methods, what kind of exceptions can come out of the method? Say this is an inbuilt method in Java. Say I'm going to call this write object method. Will this method throw any exceptions? How will you identify that? How many different types of exceptions are thrown by this method, or what are the important exceptions thrown by this method? How will you identify that? Because when you're calling this method, you have to handle the exceptions thrown by this method. There can be anything. Maybe this one throws an exception, this one throws an exception. What is the important exception that will arise? How will you know? That becomes a question. So that's why in Java they have this throws keyword, which is attached to your method signature. Let me erase all the ink on the slide, and you can see every method will also have a declaration like this: throws exception name. As a programmer, it is your responsibility to tell the others what kind of exceptions are possible from within your method. So what is that we understand here is this method is going to throw an exception called IO exception. So whenever I'm calling this method, which exception I should handle, very important exception I should handle, IO exception. So what is the use of throws keyword? It is just telling the programmer, okay, these are the exceptions that are possible out of this code. So when you're calling this method, handle those exceptions. So when I call this method, what I should do? Say I'm calling this method, which exception I should handle? IO exception. It's important and it's mandatory I handle that exception. So use of throws class, it just specifies what exceptions can arise out of a method. In what way it is useful? Because it's not that only you will be using the code that you have written. Sometimes you will be using code like this which others have written. While you are importing the classes through the packages, using the methods, you have to know what exceptions you have to handle. So in those during those times, you should look at the definition. Throws IO exception. Definitely there's an higher chance that an IO exception can arise. So I should be handling that exception in my code. So use of throws class we have given here. Say you give the method name, parenthesis, all the arguments, then comes the throws keyword. It is not throw, it is throws. S should be there. Whatever exceptions possible, say it can be arithmetic exception, comma SQL exception, comma IO exception. All the list of exceptions can be mentioned in your method signature. What is the use of that? So that you handle all the exceptions. Say even a user defined exception can be mentioned. So when I'm going to use this method, how many exceptions I should handle here? I should catch this one, I should catch this one. Let's take a demo of the throws class quickly. Let's go to this throws. So what I will do is I will delete all these things from the previous thing. And let's take a very simple example here. Let's just live with try and catch. Let's delete Satish, exception, everything. Let's have a simple example. So what we'll have here is we'll have a class student void. We'll say some test method we'll have. And this is going to throw an arithmetic exception. So we'll say throws arithmetic exception. Okay. So one of the common mistakes I used to make is I just put the throws declaration before the method name. That's a common mistake, but that will give an error. So now you have public void test throws arithmetic exception. I can have a sysout statement here. Just some blunt method divide by 0. Say when I create an object of type student and call this method, I should be very cautious. So I create an object of type student here. And then I'm going to call s.test method. If I don't handle the exceptions, it's going to crash. How will I handle the exception? Now I know it's going to throw arithmetic exception. So I will be catching arithmetic exception here, and then sysout. We'll say arithmetic exception caught. You see the advantage of throws. You take a look at a class written by someone else, you'll not understand what all exceptions can arise. It may have 100 statements. So by just looking at this, I know. No need to even go through the method body. By just looking at this, I'll handle it here. So let's run this. Let's check. Arithmetic exception caught. So like that, it can have many other exceptions too. Say if you are going to have input mismatch exception handle, you can just mention that. Put a comma and mention all the list of exceptions that will be arising. There's a possibility of such exceptions coming out of your method. So when you are calling this method, what you have to do? Say when I'm calling this method, I should enclose that within try catch and handle it. Are you all clear with throws class? So that's about throws. So what all keywords we have taken a look at: exceptions, try, catch, throw, and throws. Another question now: can an exception arise within a constructor? How will you handle such exceptions if it arises within a constructor? Can an exception arise within a constructor? Can throws keyword be used within a, can throws be used alongside the declaration of a constructor? Let's take a demo of this. So we have this class student. Let me take a constructor here. Let's take some method data members. Let's take string name. Let's take and int marks. We'll take. We'll have a parameterized constructor, or we'll have a constructor like this. I just want to create an exception here. So what I will do is I will initialize something like this, or else I'll get the input from the users. So to enter the name. So let's. I want to just create an exception within the constructor. That's my goal. So let's create a scanner object. This is system.in. And now what we'll do is we'll say this dot name is equal to input dot next. That is s dot next. And then sysout enter the marks. Enter the mark, and here I can just say this dot mark is equal to s dot next int. Very simple. Now what I'm trying to do is I will not handle any exceptions. I just create an object of type student. Student Satish is equal to new student. Let me run this. Let's check what will happen. What is our objective here? Whether a constructor can throw an exception. So let me enter Satish, and mark I'll enter Satish again. So what we understand here is a constructor can throw an exception too. So in that case, can we have a throws declaration with a constructor? Yes. I can say throws input mismatch exception. Okay. Is this solving my problem? Can I run this? Will this solve my problem because I given throws declaration there? How to handle this input mismatch exception? Say I'll give Satish again and Satish. So how to solve this? So you should put this inside the try catch. When the exception occurs, when you are creating an object, that exception occurs. So you put your entire object creation inside a try catch, and whatever exception is bound to happen, input mismatch, you catch that here. This out, you can say enter the correct input. So now when the object is getting created, this one runs. When an exception happens, it will be handled here. Let's run this. So enter the name. It's running inside the constructor Satish, and then I'm giving Satish. Input mismatch exception occurs. It's handled in the main. So while you're creating an object, an exception can occur even here too. So even that you can handle. And what we understand here is exceptions can arise within your constructor too. It's possible. When you think an exception can arise within a constructor, you can have throws declaration for your constructor too. So these are some of the understandings we have. So you are now convinced constructors can throw exceptions, and you have to handle them while you're creating the objects for those specific classes. So what is that we are going to discuss now is we are going to discuss on the finally block in Java. So what is the use of this finally block? We already know how to handle exceptions. The keywords are try, and then we have to handle catch. We all know how to handle exceptions. This is you need a try. What is mandatory? After the try, you definitely need a catch. So let me create an exception here. Sys out. I just throw an exception. Say divide by 0. So arithmetic exception will happen. How will you catch this? You need an handler here. The arithmetic exception we catch, and we'll throw this message e dot get message. Okay. So this we know. Let me type this e dot get message. So this we know. Now we are taking a look at this block called finally. So that comes next. It's a block of statements. What is the use of this block is you have any resources that you want to release any resources. What do you mean by releasing resources? Your program can make use of a file, write to a file, read from a file. Your program can write to a database, establish connection with the database. So it will be holding on to some resources. When you're done with your computation, you have to release these resources so that it can be utilized by other programs and applications. So here resource release code happens. Say for instance, I have a scanner. So I create a scanner here. Input is equal to new scanner system.in. So I have the scanner. One thing you have to know is after you use your scanner, you have to release the resource. So you have to close your scanner. So input dot close. So I can use the finally block for such code. Here I'm just giving an example. So now what happens when an exception happens? What will be the scenario here? It will be executing this code. An exception happens, so you will come here, handle it. After this, the finally block will also execute because it should execute to release the resources. So let's have a sysout statement here. After this input dot close, let me have a sysout statement saying all resources released. So try will execute, an exception happens, it will be caught here. After the exception, definitely the finally block will execute and the resource will be closed, and then all resources released will be printed. So let's run this code. Let's check what is the flow here. See, divide by 0, exception handled. After the exception, finally block executes. If there is no exception, say I don't have any exception here, no exceptions in my code. I'm not throwing any exceptions. Now what will happen? Will the finally block execute? The answer is yes. Whether there is an exception or not in your code, your finally block will execute because it should release the resources. So what you understand from finally is whether there is an exception or whether there is no exception in your code, this will execute, this block will execute. Maybe your program is going to crash, but you have to release the resources. So that's the concept here. So finally is used like this. There's one more way wherein you can use finally. I'll tell you that way too. So what is that we have learned? After try, what should come? Catch should come. But in Java, this is allowed. I mean, after try, you can have a finally block. This sounds a little weird, right? You are not catching the exception here, but you are allowing a finally block. So if there are no exceptions, what will happen? It's going to print no exceptions in my code and finally block will execute. Absolutely no issues here. But if there is an exception that's happening, will this really work? Say if I have an exception created here, how will I create an exception? Yeah, I'll just divide by 0, throw this exception. Am I catching it here? No, I'm not catching it here. So in that case, definitely you're going to end up with an issue here. See, there is a scenario wherein you can have a try followed by a finally without a catch. But when an exception occurs, it's going to definitely crash your program. And you have to keep in mind, you can't have a catch after finally. You can't perform this. The catch, if you're going to have a catch statement, where it should be immediately after try. If you're not going to have a catch, then it's fine. But then what should come next? Finally block should come next. So these are the only two cases. Say if you're not going to have a finally, then you can't have a try to. It'll be an error. If you want to avoid that error, you can have a finally. But if you want to have a catch, where will you have that? You should have the catch immediately after the try block. So this finally, what we understand from finally is whether an exception occurs, an exception does not occur, your finally block is going to run. So when finally, how you're going to have finally, it can follow your catch block or it can follow your try block. So you may have some questions. What is the use of this? Without catching the exception, how can I even have this? Yes, you will see the use of this in another concept that is called nested try catch. So we will see this final concept on exception handling, that is nested try catch block. It's very similar to your nested if else, nested loops. What is nested try catch? You have a try block and then you have a catch. So this is where you catch. Now within this try, you nest another try catch. That's it. So you're going to have a try, and then whatever you're going to try here, you'll catch it here. So you're going to nest. What is that we understand from here? This try catch is nested within this try catch. So you call that to be, this one is called, what is this internal one is called? A nested try catch. So there are some rules with respect to nested try catch. Whatever exception happens within this nested try catch, say I'll just write and create an exception here. Sys out 4, 0. So an arithmetic exception is happening here. So this exception, which is happening internally within the internal try catch, can be handled here immediately. You can handle it here. This out, we can say e.getMessage. Okay. Whatever exception happens within the internal try block will be handled within the internal catch block. Let's run this code and check what happens. Okay. I have to also handle something outside. We'll take up this one. Whatever exception happens in the outer try block. Say if I have an outer try block exception, arithmetic exception. So if an exception happens here, where this should be handled? This should be handled in the outer catch block. Let me handle the arithmetic exception here. And let's put a sysout statement saying, let's say handled in the outer block. I'll just put some messages here, handled in the inner block, like that. What is that we are understanding? If an exception happens in the inner block, it will be caught in the inner catch. When exception happens in the outer block, outer try, it will be handled in the outer catch. Let's execute this. First, what will happen? An exception in the outer block will happen. It will be handled here. And then the next statement in your code will print sys out. Thanks for using our software. God, using our software. So first let's take a look at this one. This will throw an exception. This is in the outer try where it will be caught in the outer catch block, and then it will go to the next statement. Let's run this. Let's check the output. Handled in the outer block. Thanks for using our software. Suppose an exception happens in the internal try where that should be handled. It will be handled in the internal catch block. Let's run this. Handled in the inner block. So what is happening here? This is the internal try creating an exception. It's getting handled in the inner block. What you understand here is any exception happening in the outer try will go to the outer blocks. Inner try will be handled in the inner catch block. So now comes this concept. What happens if I don't have a perfect handler here? I'm not handling it here, but I have a finally block here. I am saying sysout resources released. I'm just releasing some of the resources that I don't need after this point. Now I'm not handling this here. So this exception, what will happen? An exception object will be thrown of type arithmetic exception, but you don't have an inner handler here for this. So what it will do, you have only a finally block. So if an inner handler is not available, it will automatically search the outer catch block, whether an handler for arithmetic exception is present in the outer catch block. If there is an handler in the outer catch block, then definitely this outer catch block will handle this inner exception. Why it is going to the outer catch block? Because you don't have a catch to handle the exception that happened for the inner try. Let's execute this and let's see. Resources released. So finally block executes. See, exception occurred, finally executes, and then that exception is handled in the outer block. So now it makes some sense, right? Why we have try with finally alone. You can have it in your inside, in your nested try catch blocks, you can have something like this. Any exception that is not handled internally will be handled in your outer catch blocks. If you don't have a specific exception and say I am not handling arithmetic exception even in my outer catch blocks, I have just a null pointer exception handled here, what will happen? If this is the case, what will happen? Definitely you're going to get your program is going to crash. But what's happening here? Exception next finally block will execute whether an exception happens or not. If you have finally, it will execute. Then this is thrown to the outer block since we don't have an inner handler. In the outer block, you don't have any arithmetic exception handler, so it crashes. So what you have to understand is, if you have an internal try, either you should handle it with an internal catch. If you're not handling it with an internal catch, you can put a finally block in that place, and then you have to handle that in the external catch blocks. Very simple, but very, very important. So I can handle that here. So now you would have understood the use of finally block and then how finally can work with nested try catch blocks. So anything that you have in the outer blocks will be handled in the outer catch. Anything that is there in the inner block should be handled in an inner catch. If an inner catch is missing, then it will be diverted to the outer catch blocks. So we have completed our concepts on exception handling. What all we have discussed on exceptions. We started off with what is an exception, looked at the definitions, and then we looked at the various inbuilt classes for exceptions in Java. You understood arithmetic, null pointer exception, input mismatch exception. We went through the inheritance hierarchy of exceptions. And then what we went through finally, we also looked at user defined exceptions, how to have inheritance between user defined exceptions. Nested try catch blocks we have seen, and we have seen the use of finally with nested try catch. Not only that, we also discussed on constructors and how constructors can throw exceptions and how you have to handle that. We all remember the difference between throw and throws. What is the use of throw keyword? The 5 keywords you should now remember. Try is for enclosing your code wherein you think an exception will happen. Catch is for handling that object, catching that object and taking appropriate actions. Whereas throw is for throwing an object, exception object of your choice. Throws is for declaring the exceptions that will occur in the method signature. Finally, block is for releasing the resources and it will execute whether an exception occurs or not. So with this, we'll wind up our fourth module, I guess, fourth or fifth module, not sure. So that exception handling concept is done.